Welcome to lesson 18, problem number 3. In this lesson, in this problem, we are combining what we've learned in this lesson. We know how to factor out the greatest common factor, and we know that's our first step always. Then we know how to factor binomials, where we take the difference of two squares. We know how to factor that. This lesson will combine those two concepts. So let's get going. The first step here is to take the 3 to the outside. That is our greatest common factor. Now we can factor again by doing the difference of two squares, x minus 10 and x plus 10. But don't forget, you need this 3 as part of your final answer. Guarantee if you multiplied all this out, you'd be right back at 3x squared minus 300. Okay, the next one, 25 is our GCF, so we have 25 times 9 minus k squared. So we leave the 25, we have to rewrite that, and we have 3 minus k and 3 plus k. And we are done. Let's circle that one as well so you can see the final answer. Okay, the next one, we're going to take out a 5, and we're going to have x to the 4th minus 10,000. Okay, now we have 5, and we're going to take the difference of two squares. So it's going to be x squared minus 100 and x squared plus 100. This cannot factor again. That is prime. We can't do anything with it. But we can factor x squared minus 100 to x minus 10 and x plus 10. And then we just rewrite the x squared plus 100. And what I'm circling in blue is our final answer. Done. Okay, let's look at the next one. So this is it's a light bulb one. In fact, that last one was light bulb too. I forgot to even mention it. Okay, so there's no GCF, so we're just going to do the difference of two squares. So we're going to take the square root of the first term, x minus 3, and then we're going to say x minus 3 minus the square root of the second, but notice I'm putting it in parentheses. So it's x minus 3 minus the quantity k plus 8, and then it's going to be x minus 3 plus the quantity k plus 8. But I don't really need a parentheses when it's just a plus. So now I'm going to rewrite this nice and neatly, x minus 3 minus k minus 8, and this becomes x minus 3 plus k plus 8. Now when we combine our like terms, we simply have x minus k minus 11, and over here we have x plus k plus 5. Done. Okay, another light bulb. All right, what's really tempting to do with this one is to say it's x to the 4th minus y to some power. But it's not. The square root of x to the 16th is not x to the 4th, it's x to the 8th. So we have x to the 8th minus y to the 4th. And the reason it's that is because x to the 8th times x to the 8th is x to the 16th. So we have x to the 8th minus y to the 4th and x to the 8th plus y to the 4th. Again, this is a very tricky light bulb. Okay, this difference of two squares can be factored again. So now we have x to the 4th minus y squared, x to the 4th plus y squared. So I'm going to kind of underline just to make sure you see this quantity became these two. What I'm underlining in blue, not sure why I'm not getting that to be blue. What I'm underlining in blue just stays. So I'm going to leave that as x to the 8th plus y to the 4th. That cannot be factored again. Okay, only one of these can be factored again, and it's this one right here. So that now becomes x squared minus y times x squared plus y. Then we still have the x to the 4th plus y squared, and then we still have the x to the 8th. Let's just kind of make that look a little bit nicer there so that that doesn't get so messy. And that last one is x to the 8th plus y to the 4th, and we are done. So we have 4 parentheses this time. Nothing else can be factored. Okay, look at this last one, and what we have is we basically have a minus b as our GCF. So it's a minus b times the quantity a minus b squared minus 49. And now we can leave out that a minus b, which is our GCF, and the part that I'm underlining in green, is going to be these two parentheses. So that is now going to be a minus b minus 7 and a minus b plus 7. And we're done. All right, great job. Those light bulbs were challenging. Way to hang in there.